Okay, let's talk about another type of index that can be very useful when dealing with text. It's called a full text search index. Full text search was first introduced on an experimental basis in MongoDB 2.4, and now it's available for general availability in MongoDB 2.6. So why would you use it and what would you use it for? Well, let's say you had a very large piece of text that was in a document, something like the US Constitution, which starts out, "We, the people of the United States, in order to form a more perfect union." Let's say you had that document right here in a key called my text. And then you had the entire preamble to the US Constitution in this key my text. And you wanted to search it. Well, if you search just on any given word, then you wouldn't get anything back because MongoDB, when you search on strings, the entire string needs to be there. So as an alternative, you could put every single word into an array and then use the set notation operators to push things into it and then search for whether or not the words are included. But that's pretty tedious. And there are certain other features that would be missing. So instead, what we have is something called a full text search index, which is abbreviated text, which will index this entire document and every word, much in the way an array is indexed, to allow you to do queries into the text, basically applying the OR operator and looking for one of several words. So let's go look at now a specific case and see how it would work. All right, we've created a collection called sentences, and this collection has got a bunch of mostly just randomly inserted words into a words key. Now, if I wanted to search, and there is no text search index on this right now, this is a regular collection. If I wanted to search for, let's say, dog, shrub, ruby, I could do it. I could do, all right, there we go. So I searched for dog, shrub, ruby, and I found this document with words dog, shrub, ruby. But it's very particular. If I leave off the period, it doesn't find it. If I just do dog, ruby, it doesn't find it. And if I just do dog, it doesn't find it. That's not going to work too well for me to search on these different words. So now let's add a text index. So db.sentences.ensureIndex, and now I want to put an index on words of type text. There we go. And now when I search it, dog, shrub, ruby, it's going to work a lot better. So let's do that. So let's first look at the syntax for searching a full text index. The way it works is I have to say $text and then give a document with $search and then what I'm looking for. So we saw that, for instance, dog did not work before. Let's just look for dog now and see if that works. There we go. Okay, so now I searched for just the word dog and I was able to get all of these back that have dog, moss, ruby, dog, shrub, ruby. And then just to show you again, when I just search for dog using a regular search of words, I don't get anything. But if I search using a text index, I'm going to show you the syntax right here. I search using a text index by specifying $text and then $search, and then what I'm looking for, dog, I do get documents back. I get all these documents back because they all have dog in them. And if I also say moss, I get all of these back as well. And if I say moss ruby, I'm going to get all these back. And it's quite flexible. Putting in a period makes no difference. Capitalization makes no difference. So it's going to also ignore certain stop words that are not considered to be significant, like and the in the English language. So that's really very useful if I want to search for a bunch of different words and essentially apply a logical OR operator. Now, there's one other thing I wanted to show you, which is how you can get back these in an order that indicates how good a match MongoDB believes there is. So let's look for one of these. So I'm going to show you the syntax for this. All right, so let's look for dog tree obsidian. Okay, dog tree obsidian. Let me go back and change this. And we can see the document right up there with dog tree obsidian. I mean, the best match for dog tree obsidian should be dog tree obsidian document. But we're going to do something special now. We're going to project a score field, and we're going to use a special $meta operator and then take the text score, which is something that's internally computed as it runs through this text search. And we're going to get that text score out, and then we're going to sort by that text score. And we're not going to test you on this syntax, but I want you to know it exists if you ever need it. And if you do that, you'll see that now it's ranking the documents in order of their text score, and that if you're searching for dog tree obsidian, the one with the highest score, a score of 2, is the document with dog tree obsidian, all 3 words in it. Very useful if you want to find the best match for, let's say, a document that contains all the words. All right, so now it's time for a quiz. Let's say you create a text index on the title field of the movies collection. You imagine having a movies collection, and then perform the following text search: db.movies.find, $text, $search, Big Lebowski. Which of these documents might be returned if all of these documents are in the collection?